back to my channel. My name is Prachi Sharma, and in today's session, as promised, we will be covering the IUPAC naming for organic compounds. We'll start with learning the rules on how to name a formula if it's given to you. And in the second part of the video, like as we go along, we'll also study how to make the structured formula from a name given to you. Stick around till the end of the video, as at the end I also have some mixed homework questions for you. And as we go along the video, we will keep practicing some questions and understand the rules that we have. So stick around and let's get started. Alright students, so we are starting this session now. This session that I'm starting off is with the basic understanding that you are aware of what organic compounds are, how carbon is making long chains, what alkanes, alkenes and alkynes, the basic information what they are. So what I'm starting off from, I'm starting from the basic knowledge that carbon bonds are present. You can have a single bond, a double bond or a triple bond. So the basic understanding is that alkanes are forming C and C single bond carbon chains, anes. Then alkenes give you double bonds, so C double bond C, and alkynes are giving you triple bonds. All right, so you have C triple bond C. This is my basic understanding that I have three types of organic compounds here. Now, general formula, that is CnH2n plus 2, CnH2n, CnH2n minus 2. Now, if you do not know this, then please go ahead, watch the video on organic chemistry first, and then come on here and understand the naming of IUPAC. Now, let's get started with the root words. So, you understand you have three homologous series: alkanes, alkenes, alkynes. Now, we are talking about the root words. That means if you have a single carbon, then you have meth. 2 carbons, eth. 3 carbons, prop. 4 carbons, bute, and so on. Okay, this means that if I'm talking about alkanes and I have a single bond and I have 2 carbons here, so 2 carbons, meth, eth, so this will be ethane. Then same thing for alkene, so this would be ethene, and this would be ethyne. Okay, so this is the basic understanding that these are your root words that will help you understand the naming. Okay, now moving on, you need to learn these, so make sure that you take a note of this or a screenshot of the root words and learn them. One more thing is that your alkenes and alkynes, that is double and triple bond series, start from eth, because you cannot have double or triple bond on a single carbon. So methene and methine does not exist. Your alkenes and alkynes start from eth, that is 2 carbons minimum. Now let's move on. Now the first, let's look at a few examples. So for example, I have the carbons here. So 1, 2, 3, 4, 5. And all of them are single carbon, single bonds. So this would become what? 5. So pent. So you write pent. That is your root word from here, pent. And since all of them are single bonds, you go for alkanes. Okay, A-N-E. So this becomes pentane. The second one is a double bond. Okay, so a double bond means you are at ene. E-N-E. And how many carbon atoms do we have? 1 and a 2. So meth, eth. So ethene. A-T-H, ethene. Okay. Now moving on. 2 carbons. So 2 carbons is eth. And a triple bond is ine. So ethine. Okay. Now let's look at the first rule of IUPAC naming. That is selection of a carbon chain. So you are supposed to look for the longest carbon chain in whatever compound that is given to you. Okay, let's look at the first one. Now once you have identified the longest chain, that okay, this is my longest chain, okay, then you start naming it. That means you start numbering it. So 1, 2, 3, 4, 5. Okay, so this gives you the root word. 5 will give you a pent. All single bonds will give you and ane. Okay, now let's move on to this example. First thing you are supposed to do is identify the longest chain. So now let's look at all the carbon atoms. So longest chain can be this. Okay, so starting from that and coming down. So this would be 1, 2, 3, 4, 5 and a 6. Okay, now a lot of students may think that, ma'am, okay, we can do like this, like these are 5 and 2 carbons are here. Okay, so the last carbon that you have, this carbon can also be written as 1, 2, 3, 4, 5 and a 6. That means the last carbon that you have in this chain can be written in the straight line. So it is part of your carbon chain. Okay, identify the longest chain. So this is my longest chain in this case. If I try to name this longest chain, I have 6 carbon atoms. So my root word is hex. Now all of them are my single bonds. So ane, hexane. Okay. How we name this carbon here, we'll come on that. For now, I'm just helping you identify the longest chain and identify what group we are going in. Are we going in alkanes, alkenes or alkynes? Okay, so let's identify the longest chain. Now if I have this example, will my longest chain be this? This gives me 3 carbon atoms. So no, this is not my longest chain. What my longest chain will be, it can go from like this: 4 carbon atoms, 1, 2, 3, 5 carbon atoms, 1, 2, 3, 4, 5. Or you can also take it as like this: 1, 2, 3, 4, 5. Okay, 5 carbons should be a part of your chain. So anyways, you can go like this or like that. It's up to you. So identify the longest chain, 5 carbons. Moving on to this one. Now, a lot of students can go as the longest chain as straight. So if I go straight, how many carbons do I get? I get 1, 2, 3, 4, 5, 6, 7, 8. I get 8 carbons if I go straight. Now I'll just quickly check. If I go like this, how many carbons am I getting? 1, 2, 3, 4, 5, 6, 7. So no, this is not my longest carbon chain. Can I go from here like this? 1, 2, 3, 4, 5, 6. This has only 6 atoms. So no. Which is my longest chain now? Let's mark that. So the straight line like this will be my longest chain. So you can number them: 1, 2, 3, 4, 5, 6, 7, 8. Your longest carbon chain. Okay. Now moving on to rule number 2. The carbon atoms of the longest chain are numbered in such a way that the alkyl groups get the smallest number. What is alkyl group? Okay, you have to consider 2 things. Now the first thing is you are able to identify what is the longest carbon chain. The second thing is, from where should I number 1, 2, 3? Should I number it from this side or should I number it from the other side? How do we know that? Okay, so for in this example, you had all of them as single bonds, but you have this double C's attached somewhere here in the middle. So you have to number the carbon atoms in such a way that this thing, this is alkyl group, that this thing gets the smallest number. Okay, so if I start numbering them from this side, 1, 2, 3, 4, 5. So my alkyl group is coming on number 5, and if I'm numbering them from left to right, my alkyl group is coming on 4th position. So I'll be selecting moving from left to right. That means your alkyl group should be at the smallest number possible. Okay, Now, what all do we prioritize? So you will prioritize alkyl group, anything that is a branched chain, or you have a double bond, triple bond, you'll also prioritize that. For example, if I have single bond C like this, and I have a double bond here, okay, so 1, 2, 3, 4. No, this is a wrong numbering. You will not go from left to right. You will prioritize the double bond. So you'll come from that side. So you'll be like 1, 2, 3, and a 4. Okay. So you'll prioritize double bonds. You'll prioritize alkyl groups. What is alkyl group? A branched chain. And number 3, you'll prioritize a functional group. Functional group is anything like bromine, chlorine, alcohol. So OH, okay, hydroxyl ion. So all of these will be prioritized in the chain. That means you select the numbering from that portion. Okay. Now, this is rule number 2. The carbon atoms of the longest chain are numbered in such a way that the alkyl groups get the smallest number. Okay, now let's look at this. Now, identify the longest chain. So, the longest chain is straight ahead like this. Now, from which direction should I number it? I could number it from 1, 2, 3, 4 and 5, or I could number it from left to right. Now this branched chain of C is closer from the left side. So I will number it from the left side. Simple. So let's get rid of the numbers. So 1, 2, 3, 4 and a 5. Okay. So this is the way you will number it in. Now how do we identify? Like let's move forward to the next example. On this one, this is a straight carbon chain. Your triple bond is closer from the left side. So you start from 1, 2, 3, 4, 5, 6 and a 7. Okay. Now quickly pause the video. Look at this example and drop a message in the comment section and tell me which direction will you number it from. Will you number it from left to right or right to left? Okay. Let me tell you the answer for it now. So it is 1, 2, 3, 4 or 5. So this is your longest carbon chain, but the numbering will not go from left to right. Since your alkyl group is closer from the right side, so we will number it from right side. 1, 2, 3, 4 and a 5. Alright my students, I hope this much is understandable for you. That means selecting the longest carbon chain and prioritizing the numbering from which side you're supposed to number them out. Okay, moving on. I have another example. So go ahead and give this a try. Okay, drop me a message in the comment section and tell me what was your correct answer. Now move ahead to the alkyl groups. Okay, what all types of alkyl groups you can have. So if you have a meth, that means you have a single CH or a single carbon in the branch chain, then you go for meth. Okay, and you attach a YL with it. So methyl. So if it's written methyl, that means you have a single carbon chain. If I say that, okay, over here I have a C here. Okay, so you will number it like this, like 1, 2, 3, 1, 2, 3, and all single bonds. So this will become propane. And at the second position, you have a single carbon. So this will become methyl. So at what position? You'll say 2 methyl. So you give the position 2 methyl propane. Okay. Now instead of C, if I had something else, let's look at an example. So like for example, this one becomes 2 methyl propane. Let's look at another example. If I'm going like 1, 2, 3, 4 and a 5. Okay, at 3 I have 2 carbons I have branched out. Okay, so if I have 2 carbons branched out, this gives me ethyl. Okay, so you have ethane, 2 carbons, get rid of the ane and write YL with it, ethyl. Okay, so this example will become what? At third position I have ethyl. So 3 ethyl pentane. Okay, I hope this is something that you understand. So similarly, you have propyl or butyl. Okay, butyl will have 4 branch chain. Propyl will have 3 carbons in the branch chain. Now let's move ahead and look at a few examples. Okay, for this one, write the IUPAC name of the following. So identify the longest carbon chain. So this is my carbon chain. Double bond is closer to the right side, so I will name it from the right side. 1, 2 and a 3. Now, this is what? 1, 2, 3. Prop. Okay. So 3 is prop. And you have a double bond. So this is propene. Okay. Now, if this was a longer chain, because if I look at my position of double bond, I can also write this as prop 1 ene. But since it is the first position only, it doesn't matter. Okay. Because even if it was from the other side, it will still be prop 1 ene. So you can write prop 1 ene or you can write prop ane. Now, the second example, let's look at the longest carbon chain. So 1, 2, 3, 4. Numbering will be closer from the right side. So 1, 2, 3, 4. At number 2, I have a methyl group. Okay. So first of all, how do you always start it? Identify the longest chain. Write the root word. So this is what? 1, 2, 3, 4. But. So write but. Is it all single bonds or double bonds? It is all single bonds. Simple. So you have ane. Right? So you have butane. Okay. So this is butane. Then you at second carbon you have a ethyl group, a methyl group. So what? How will you write it? You will first write methyl, and then you give it the position. So 2-methyl butane. Easy. Let's move on. How many carbons do I have here? The longest chain, no matter which direction you take it, the longest chain will be of 3 carbons. Okay. So you can select whatever chain you feel like. So I am selecting the basic straight chain. So how many carbons do I have? I have 3 carbons. So 3 carbons mean prop. So I'll write prop. Do I have double bonds or single bonds? All single bonds. So ane. Prop ane. Now, one interesting thing. Instead of, let's say I'm naming it like this. Instead of having 1, I have 2 methyl groups here. I have 1 below, I have 1 above. Okay. And both of them are at position 2. So how do I write it? First I'll write methyl. Then I'll give in the position. I have 2 methyls. So I'll write 2, 2 dimethyl. So 2, 2 dimethyl. Di means 2 methyl groups are present at position 2. Okay. If it was more than if it was not 2 at 2, if it was at a different position, then what will we do? We will do that. For example, it's at 2 and 4. So we'll say 2, 4 dimethyl and whatever chain you have. Is it propene, propyne, propane, whatever. So 2, 4 dimethyl. If it was more than 2, then tri, then tetra. Okay. So this is how we will go. Now let's look at this one. Now you guys try this one. So I have the longest chain like this. 1, 2, 3 and 4. 4 means but. All single bonds means ane. Butane. I have 2 methyl groups at position 2. So 2, 2 dimethyl butane. Okay students, easy. Let's move ahead to this one. Okay, in this one I have 2 double bonds. So let's see how do we name that. So I'll first name the carbon chain. So I have 1, 2, 3, 4 and 5. Why am I not numbering from the other side? Because my first double bond is closer from this side. It is getting the position of 1. Okay. So let's name this. So first of all, it is 5 carbons. So I'll go for pent. Then I have 2 double bonds. Okay. So I'll name the position 1, 3 ene. Okay. So pent 1, 3 ene. Okay, so that means at 1 and 3rd position, both of the position I have a double bond. Okay, sorry, this would be diene. Pent 1, 3 diene. That means 2 double bonds. So diene. 1, 2 diene. Alright students, let's look at the functional groups now. So we understand the alkyl groups, that means any branched chain of carbon that you have. Let's move on to functional groups. Okay, so functional groups can be chlorine, bromine. For example, you can have halides. Okay, you can have halides, and the examples are also right here. Fluorine, chlorine, bromine, iodine. Okay, they will be attached as Rx. That means I have CCC, chlorine is here or anywhere. Okay, any position. Then hydroxyl, OH. This is alcohols. Okay, and it is represented or written as suffix is written as OL, all. Okay, aldehyde, that means a CHO. Okay, one thing is that when you have alcohol OH, it can be anywhere in the carbon chain. I have a carbon chain like this, OH is here or OH can be at the corner. No worries about the position. OH can be attached anywhere in my chain. So that is alcohol, OL. Then I have aldehyde, CHO. Okay, now in CHO what happens is that it should be a double bond O. Okay, so a double bond O can be anywhere in the chain or at the corners also. There is no problem with any attachment. So it can be like this, double bond O, or it can be CCC and at the corner double bond O. Okay, so wherever you see a double bond O, that means you have a aldehyde and the suffix is Al. Okay, now moving on, if you have a carboxyl, that means carboxylic acids. So this is COOH. That means this you will generally find towards the end of a carbon chain, because if you have a carbon chain like this, towards the end you have a double bond O and a single bond OH. Okay, so generally it is found towards the end of a carbon chain, because these if you look at this, you have 1 2 3, right? You have 3 bonds already, so you are left with just 1 bond. So that means it is at the end of a carbon chain. You do not attach a carboxylic acid or COOH anywhere in the middle of the carbon chain. It is always at the end. At the end or at a corner. That means it can also be something like 1 2 3 4, and over here you have a C, and then from this C you have a carboxylic attached to it. So double bond O and a single bond OH. This can also happen. But always remember, your carboxylic acids are towards on the corner carbons, not in the middle chain. Now let's come back. So now ketos and your ethers are not in the syllabus this year, so we won't be doing that. Now let's take a quick recap. Let's take a quick example and quick recap. Okay, now I have a carbon chain. Now if I have a bromine or a chlorine, iodine, anywhere on the chain, okay, these are halides. Okay, moving on, if I have alcohol, single bond OH, you have a carbon chain, anywhere, single bond OH, here, here, anywhere, alcohol represented as OL. Then double bond O, anywhere on the chain, double bond O. Okay, anywhere on the chain, double bond O is what? Aldehyde. Double bond O, aldehyde, represented as Al, written as Al. Carboxylic, COOH. COOH is always at the corner carbons of the formula, never in the middle. So do not get confused. Your COOH is never in the middle of the chain, always on the corner carbons. Okay, double bond O, aldehyde. The COOH, your carboxylic acid. OH, alcohol. Okay, make sure that you learn these thoroughly. Now let's move on and look at a few examples. My students, if you want to give them a try, keep pausing the video, try them and then check the answer. Now let's move on to the first one. So you have 4 carbon atoms. So I'll be naming it from this side. 1, 2, 3, 4. 4 carbons means bute. I'll write bute. All single bonds means ane. And at second carbon, I have a halogen, that is chlorine. So how will I write that? I will write 2-chlorobutane. Okay, 2-chlorobutane. One rule that you have to understand is that all the numbers are separated by a comma, and a number and an alphabet is separated by a dash, a hyphen. Okay, so it is separated by a dash. Now let's try this one. So naming from this side, 1, 2, 3, 4, 5. Okay, 5 means pent. So pent. On the second carbon, I have OH, that means alcohol. So pentanol, pentane, AN. Okay, because all are single bonds. At the second carbon, I have alcohol. So pentan, 2 all. Okay, pentane, 2 all. Pentanol. Second carbon has OH. Moving on. COOH. Now, C double bond O, single bond OH. Now you see, this is at the corner carbon. How many carbons do I have? I have 3 carbons. So propane, because all single bonds, oic acid, propanoic acid. If this was anywhere, if you had a double bond in the chain, that would become propene, propanoic acid. Okay. Now moving on, 2 carbons and 2 bromines. So 2 carbons means meth, eth. So eth, ane, because all single bonds, eth, ane, and 2 bromines, and both of them position is 1 and 2. So 1, 2 dibromoethane. Okay, 1, 2 dibromoethane. Let's practice another question here. So how many carbons do I have? I have 1, 2, 3. But do I name the chain from that side? No. I'll name the chain which is closer to my alcohol. So 1, 2, 3. 3 means meth, eth, prop. So I'll write prop, ane, an, because all are single bonds, and ol, alcohol. Now since alcohol is at position 1, it's not necessary that I give in the number. So propanol. Okay, not necessary to give in the number. Now moving on. 1, 2, 3. 3 carbons. Quick. Prop. All single bonds. An. At the second position, I have alcohol. So propan, 2 all. Moving on. I have 3 carbons. 3 carbons as in prop. I have a triple bond. That means propyne. YNE. Propyne. Propyne. Triple bond is at the first position. No need to give in the number. Moving on to the 8th question. 3 carbons. Prop. Okay. You have a CHO. Okay. What is CHO? That means you have. Tell me, what do you have? Think about it. First of all, prop. All are single bonds. Write AN. And then if you are confused, come back here. See, you have a CHO. CHO means a double bond O. Okay. Aldehyde. That means AL. Propanol. AL. Alright. Now, moving on. You have a double bond O again. So this is a double bond O. Now in this case, double bond O is in the center. So you'll have to give in a number for the position of this functional group. So what will this become? This will become prop. Now ane, because all are single bonds. Propan, 2, position number 2. al, Al. Propane, 2 al. An aldehyde attached at the second position in a carbon chain of 3 atoms. Make sense, students? Moving on, I have number 10. 1, 2, 3. 3 carbons. Prop. How many, let's number it from this side. 1, 2, 3. All are single bonds. Propane. At the second position, I have what? What do I have, students? I have methyl. So 2 methyl propane. Okay. Move on. Select the longest chain. Longest chain is this. 1, 2, 3, 4. 4 means bute. Single bonds. Ane. Bute. Ane. And at second and third position, I have methyls. So what do I write? I write 2, 3 dimethyl butane. Okay, students. Moving on to 12th question. Let's number the chain. 1, 2, 3, 4, 5. Pent. 5 means pent. Tent. All single bonds. Ane. Ane. At third position, I have a methyl. So 3 methyl pentane. Okay, students, I hope this is becoming a fun factor for you here. So let's look at 13th question. How many carbon atoms do I have? Let's number the chain. So 1, 2, 3, 4, 5 and a 6. 6 means hex. Hex. All single bonds. Ane. Hex. Ane. At third position, I have a methyl. So 3 dash methyl hexane. Okay, 3 dash methyl hexane. Let's move on to question number 14th. Now, let's number the carbon chain. I have alkyls here. I'll name it from right side. So 1, 2, 3, 4, 5, 6, 7. Sept. 7 is sept. Sept. All single bonds. Ane. Ane. 2 alkyl groups. 2 methyl groups. 2, 3 dimethyl septane. Okay. Moving on to 15th question. Now, let's number the carbon chain. 1, 2, 3, 4, 5, 6. Hexane. Hexane. At 3, I have 2 methyls. So 3, 3 dimethyl hexane. Moving on to 16th. Now, you can take a note of these questions, guys. You can take screenshots real quick. I have 16th, 17th, 18th, 19th, and 20th. Let's move on to writing structural formula for IUPAC names. Now, one important thing is, students, that I will attach this file in the description box, so you have a lot of questions to practice. And if you are facing any doubts, you can drop a message in the comment section and I will answer you back. Any student who will get all of them correct, I will mark that comment and I will stick it or pin it on the top of the comment section. Okay, let's move on to writing structural formula from IUPAC names. Okay, now once you can see the root word in the name, hexane, pentane, butane, the first thing you will do is draw the carbon chain. So write the number of carbon atoms according to root word. Okay, so the first thing we'll do is write the number of carbon atoms according to the root word. Moving to the second point. Number the carbon atoms from the end where the double, triple alkyl group or functional group is the closest. Okay, so whatever is giving you the number, for example 2 dibromo, 3 dichloro, so wherever you can number it the closest, you pick up that. Number your carbon chain. Once you have numbered your carbon chain and extra information that you have, you put in that. For example, alcohol. So let's say I have pentane 2 all. So that means at second position I have alcohol. Okay, so once you number the chain, start putting in that information. According to the suffix "in", "in" or "ein", put in the position of the bond. Okay. Satisfy the 4 valencies of the carbon atom by attaching hydrogen atoms. If in the exam you do not complete the valency by hydrogen atoms, then you lose marks. Okay. So make sure that you do complete that. Let's move on and let's try a few examples. Okay, students, I hope you're excited about it. Now, let's see. Pentene. Okay, we'll start with the number of carbon atoms. Pent. Pent means 5 carbons. 1, 2, 3, 4, 5. Okay. Now, pent-2-ene. Okay. Now, let me just number it. 1, 2, 3, 4, 5. At the second carbon, I have a double bond. Okay. So, 1 and 2. Second carbon, I have a double bond. Now 2-bromo. At the second carbon, I have a bromine. 4-methyl. At the fourth carbon, I have a methyl group. That means a CH3. Now just complete up all the H's that you need. Okay, students. For example, for this one, you'll have a 3H. 1, 2, 3, a single H. For this one, 1, 2, 3, a single H. You do not need anything here, and then a CH3. Okay, let's try a few more examples. I will not be completing all the hydrogens. I'll be helping you make the structure. You can complete the hydrogens on your own. All right, my students, let's buck up and move ahead. Methanoic acid. Okay, meth means a single carbon. Meth, C. Okay, oic, carboxylic, COOH. Okay, that means double bond O, single bond OH. Okay, methanoic. Meth means one carbon. Ane means single carbon bonds. Oic, carboxylic, COOH. Okay, since no position is given, that means whatever carbon you have a double bond O and a single bond OH with it. Carboxylic, methanoic. Okay, students. Ethanol. Meth, eth. Eth means 2 carbons. 1 and a 2. An, that means single bond carbons, no issues. Al, okay, Al was aldehyde. Do you remember what was the functional group that you are supposed to write? Let's quickly come back. Okay, let me show you. Aldehyde, over here you have aldehyde, AlCHO, that means double bond O is aldehyde, double bond O. I'm repeating so that you are able to remember it. Alright, students. Now, I have 2 carbons, single bond between carbons, Al. Okay. So, double bond O. You can write double bond O from both the sides because you just have 2 carbons. Okay. So, this is ethanol. Now, ethyne, meth, eth. Eth means 2 carbon atoms. So, 1 and a 2. YNE means triple bond. So, triple bond. Okay. Now, you have acetone. Okay, ketones are not in the syllabus. This is wrong. So, you don't have that. Now, 2-methyl propane. Propane. 3 carbon atoms. So, 1, 2, 3. Ane means all are single bonds. So, we have this clear. C. 2-methyl. Methyl is CH3. So I'll number it 1, 2, 3. At second position, I have methyl CH3. Okay, 2-methyl propane. Moving on, but-2-ine. So step by step, but 4 carbons, 1, 2, 3, 4. Let's number it 1, 2, 3, 4. 2-ine at second position you have a triple bond. So 1, 2, triple bond. Okay, but 2, ion. Okay, let's move on, students. Propanol, OL, alcohol. Okay, that means a single bond OH. This is what you're supposed to add. Let's start. Propane, prop, triple carbons, 1, 2 and a 3. Propane, AN, that means all single bonds, and 2, that means at second position you have alcohol. That means at second position you have alcohol. 2 propanol. Okay, students, let's move on to the next question. First of all, ethane, okay, eth, meth, eth. Eth means 2 carbons. So 1 and a 2. Ane means single bond. No issues. Now, you have 1, 2. So let's number it. 1, 2. 1, 2. Dichloro. Dichloro means you have 2 chlorines. So 1 chlorine here, 1 chlorine here. 1, 2. Dichloroethane. Alright, students, whenever you finish making the structure, read the name again and see if you have all the information matching up. Okay, students, let's move on to the next one. 2-methyl propane. Prop means 3 carbon atoms. 1, 2, 3. Ane, A-N-E, all single bonds. And 2-methyl. At second position, I have a methyl group, CH3. Moving on, butane, 2 all. But, ane means 4 carbon single bonds. 1, 2, 3, 4. OL, alcohol, at the second position. So second position, alcohol, OH. Now students, I hope whatever we did so far made sense and it was easy for you to do. So I have some homework questions attached in this PDF. I have about, I think, 10 questions for naming the structure and 5 questions for writing the structure. All right, my ICSE warriors, this is where we finish up today's session. One thing I missed out was that let's say you have more alkyl groups. Let's say you have bromine also, chlorine also. So in that case, you will write bromine first. That means you go alphabetically. So let's say 2 bromine, 3 chlorine. So first bromine and then chlorine. Okay. So B comes first and C comes later. So go in the alphabetical order in the initial part of the functional name. If you still have any doubts in the session or if you would like to plan more questions for practice, I will be happy to help you out. Do drop a message in the comment section, and also you can go ahead and join my Telegram group, and in that case you can directly text me and ask me anything you would like. That would be a great help. I hope. Please do share any advice if you have for me, and share this video with your friends to help them understand IUPAC naming. So I hope this session was fun for you, and we'll catch up in the next one. Thank you. I hope you have a wonderful day.